fire. I said, baby, 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 I'm a fireball.
Happy Cinco de Mayo. It's still Cinco de Mayo for me. We are moving on to transformation notation. This is another one in the series of super important lessons, not only for future things to come, but for down the road, those of you wishing to take grade 12 advanced functions. We are going to learn about transformation notation and how to translate or transform points. We're also going to learn how to describe transformations. And you've done some, hopefully anyway, you did some describing of transformations in grade 10 with quadratics. So hopefully you remember writing or saying things like reflected, vertically stretched, vertically compressed, shifted left, shifted right, and so on. So we're going to go over some general transformation notation, and then you have already copied down a note on 4 functions. They're going to be functions we focus on, and you have the parent points. And then the next lesson, we're going to build off of this note plus that note you copied with all the parent points and what those functions look like to do some graphing. Also, there's a little video that I've done with some animations that tie into this note that just can help give you a visual. So if you haven't already watched it, that's okay. You can watch it before this lesson to give you an idea of some things we're doing visually. You could also watch it after this lesson to tie some things together, or you could watch it before and after to, again, help kind of solidify some of those concepts. So we're going to start right here. And if you're wondering, like, I thought you said y is gone. Well, this still has f in it. And this is actually called general transformation notation, or this is the general transformation equation. So we're going to make a note of that here, actually. So that right there is a general transformation equation. So we have y equals a, f, and then square bracket kx minus d, close bracket, square bracket, plus c. And we're going to look at this in 2 separate slides. In this first slide, we're going to focus on things that affect x. So if you have a highlighter, you might want to take it out a different color. Things that affect x are always what's inside the brackets. So k and d. So we're going to go over each one of those parameters, each one of those letters, what they do. Starting with k. So we're going to focus on k over here. And we're just going to make point form notes. If k is greater than 1, so if k is bigger than 1, it's going to be a horizontal compression. So k bigger than 1, horizontal compression. If k is between 0 and 1, in other words, a decimal or fraction between 0 and 1, so 0 is less than k is less than 1, it's a horizontal stretch. if k is less than 0, so a negative number, it's reflected in the y-axis. Reflected in the y-axis. And this can be a lot of information up front at first, but once we start going through some examples this lesson plus the next lesson, it'll start to make more sense, hopefully, with practice. The d value. So now here's where we often get confused. If you look at your formula, it is x minus d. So if d is positive, it's going to be x, say, like, let's say positive 2. In the equation, it's going to look like x minus 2. If d is positive 3, x minus 3. If d is negative, so say negative 2, well, it's in the formula standard x minus, say negative 2. Two negatives make a positive. It's going to become x plus 2. So what we're going to do here is I just kind of describe this two different ways. So if d is greater than 0, so a positive number, it's going to look like in the formula x minus some number. It's shifted to the right, so it shifts your graph to the right. You could say translates, doesn't matter. Moves. The direction is what matters the most. If d is less than 0, so a negative number, remember two negatives make a positive, in the equation it's going to look like x plus some number. That shifts to the left. The way I like to think about it is in terms of opposites. So if I was to see x minus 3, the opposite of minus is plus, and intuitively that makes sense. Positive, I think, move to the right. If I was to see x plus 5, the opposite of plus 5 is minus 5. Intuitively, minus 5 means go to the left 5. Same thing with the k value, actually. If k is bigger than 1, 2, 3, 4, 10, you would think it gets bigger. The opposite of getting bigger is getting smaller, horizontally compressed. If I see a fraction or a decimal between 0 and 1, I think smaller, but this is a horizontal stretch. So I like to think of what affects x, k, and d in terms of opposites. That's what helps me memorize what to do. We're still going to build off of that, but now we're going to switch gears to things that affect y. And that would be A and C. So let's start with A. If A is bigger than 1, it results in a vertical stretch. So it's the opposite of K. If A is a decimal or fraction between 0 and 1, so 0 is less than A is less than 1, it's a vertical compression. And if A is less than 0, so a negative number, your graph is reflected in the x-axis. C. Switch colors here. C is like D, it's pretty easy. And actually, it's even easier than the left or right. It's just as you see it. So if C is greater than 0, a positive number, it shifts your graph up. If C is less than 0, a negative number, it shifts your graph down. So that's just the verbal kind of representation of what all of these parameters do to our graphs and how they affect them. So that brings us to transformation notation. And how do K, D, A, and C, how do they help us get transformed and translated and augmented graphs from our parent functions or any function that we put through these transformations? So when you do transformation notation, you're going to start off with a capital T and then brackets x comma y. And then you're going to make an arrow. And what you do is, this is forever the rules, x over k minus d ay plus c. And what that t stands for is, so transform, and then this is your parent point, so transform these coordinates. That arrow just means to or mapped to. And then these new x and y coordinates. So as long as you can pick out all the key pieces of the equation, where's the a, where's the k, where's the c, where's the d value, you can put it into this transformation notation, and you can take a set of points, original points, transform them or map them to new points according to these rules. X over k minus d, and then ay plus c. One thing I haven't mentioned yet is that you always have to have k factored out. So maybe I will write that underneath here officially as something to remember. Always common factor the k value. So it looks like it did in those previous transformation equations. So it looks like square bracket k, open circular bracket x. You never want to have that k value attached to the x. And we'll get more into that next lesson, but we will have, I think we're going to have an example. We're not going to have an example like that this time, but you definitely will for the next lesson. Okay, so getting into our first examples, and we're just going to keep it simple. We're just going to transform these 3 points to get used to transformation notation. And then on the next lesson, we're going to pick up with this information and apply it to those 4 important graphs. And really, we don't even care that much about the linear one. That's overkill. You did it in grade 9. Quadratic, we don't even really care that much about it either, because you did it a lot in grade 10. Really, we're going to focus on the root function and the reciprocal, and then to a lesser extent, the quadratic. But we already know an easy way to graph quadratics, vertex form, plot the vertex, use the step pattern. Hopefully bringing back happy memories from grade 10. Anyways, so f of x is given by these three coordinates, a, b, and c. And we want to transform them to come up with f of x plus 1. The first thing you have to identify, looking at that function notation, that function equation, is f of x plus 1. Is that 1? Is that in your a, your k, your d, or your c value? Well, it's not the a, it's not the k, it's not the d. It is our c value. And I'm going to write this for our examples. When you get comfortable with this stuff, you don't have to write what value it is. So we're going to start here. T, x, y. And our equation says x over k minus d. There's nothing affecting x. There's no k, there's no d. So it's just x, comma, and then ay plus c. There's no a. Well, there is. It's a 1, but that's not going to affect anything. We have a c value plus 1. So this is just y plus 1. And we're going to take our coordinates. So I'm going to transform a, b, and c. So we're going to transform a, which has coordinates -3, 3. And we're going to transform b, which has coordinates 0, 0. And we're going to transform c, which has 4, 2. And we're just going to follow our mapping rules. That x comma y plus 1 is your mapping rule. So x coordinates, you just see an x there, that means they all stay the same. Now I see y plus 1, so that means take your old y coordinate and add 1 to it. 3 plus 1 is 4. 0 plus 1 is 1. 2 plus 1, 3. And now we can graph our new points. So -3, 4 is right there. 0, 1 is right there, and 4, 3 is right there. And normally you'll have like the function will be called f of x or something. In this case, we're just doing it generally. So I'll just call this a2, b2, and c2. That's not really proper form. It's just kind of simplifying what we're doing here. And according to the definitions we just went over, the verbal definitions, or what verbally happens, we said if c is bigger than 0, which that is, it shifts your graph up. And in fact, we just algebraically proved it. All of our points shifted up 1. And we're going to do this for a few times at least with these three same coordinates. Again, getting used to this. So f of x minus 3 in brackets. Is that your a, your k, your c, or your d? Well, that hopefully that is your d value. So we're going to start here. Tx, y, this is always your starting point. And now we're going to make our mapping rules. Now remember, it's x minus. So that means it moves to the right, because really that means the d value is positive. So that is x plus 3. And then we have no a or c, so y is unchanged. And we're going to do the same thing. We're going to transform our parent points. So -3, 3, 0, 0, and 4, 2. We're going to transform them according to that mapping rule. If you're wondering, do I have to write this out like this every single time? The answer is yes. If you're already into the second example, finding this easy, that's great. It is going to get more complicated. And if you are finding it complicated and confusing so far, that's okay. It's the first time you've seen it. We're going to do lots of examples. -3 plus 3, 0, and then the same y coordinate. 0 plus 3, 3, same y coordinate. 4 plus 3, 7, same y coordinate. So 0 and 3 is right there, and that was our A2. 3, 0 right there, that's our B2. Now we'll pretend that this goes to 7. 7, 2 right there, C2. And again, when the d value appears, like in the equation right now, it appears like it's negative, but remember it's always x minus standard, so really it's positive. It shifts your graph to the right. And we got that. It shifted our graph 3 units to the right. Okay, so now we've got two things happening here. Graph f of 2x minus 4. So now we have a k value and we have a c value. Txy, and our transformation notation says x over k, x over 2, and then ay plus c. And there's no a value, and there was no d value, and there's nothing else inside the brackets. That's why we didn't add or subtract anything from the x. This is just going to be y minus 4. Transform my parent coordinates. According to these rules. So x over 2, negative 3 over 2. And yes, we are 11U students, so I would prefer you use fractions. However, if it's a nice decimal, which in this case it is, negative 1.5, I'll let it slide. 3 minus 4, negative 1. 0 over 2 is 0. 0 minus 4, negative 4. 4 over 2, 2. And then 2 minus 4, negative 2. Plot our points. So negative 3 over 2, negative 1, which is negative 1.5, negative 1. 0, negative 4. And 2, negative 2. If we go back to our descriptions, remember if k was bigger than 1, which it is, it's 2, it horizontally compresses. So if you hold your left and your right hand up and move them in towards each other, you've squished the graph like an accordion, you've squished it horizontally. My c value, negative 4, it's moved my graph down 4. So we've squished it horizontally, we've compressed it like an accordion and moved it down. Everything that we've done backs up our verbal definitions. They're kind of like a check and balance system, a self-check for when you do these. Okay. So this has got everything in it. I think you're ready. So one important point that I made earlier, always make sure that k value is factored out, which in this case, if you look, k is factored out. If by chance you saw 3x, I'll even write this. If you saw 3x minus 15 like that, you'd have to common factor out the 3 to get this. Okay, starting point, forever and always, Txy. Our mapping rules, x over k. So our k value, right, 3, x over 3. My d value, it looks like it's minus 5, but we know that's plus 5. My a value, 2, so 2y. My c value, plus 1. Take your parent points, negative 3, 3, 0, 0, 4, 2. And we're going to apply those mapping rules to these points. We're going to transform them to new points. Negative 3 divided by 3 is negative 1, plus 5 is 4. 2 times 3 is 6, plus 1 is 7. That's 5 and 1. And now we're going to end up with a fraction here. So 4 over 3, okay. 4 over 3 plus 5. That's not a nice decimal. It's going to be like 6.3333333, blah, 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 right? So we want to leave that as a fraction, which is 19 over 3. And then 2 times 2, 4 plus 1 is 5. So A is going to change or be transformed to 4, 7, 4, and we'll pretend that's 7 there. So there's A2. B is going to be transformed to 5, 1, 5, 1. And then C, 19 over 3, which is roughly just over 6. So we'll say that's 6 right there. And 5, so just over 6 and 5 right there. So let's go over all of our transformations verbally. K is 3. That's a compression horizontally. So we've squished our graph in like an accordion by a factor of 3. Then we moved it to the right 5. A is 2. That means we've vertically stretched it like an elastic up and down. So we've stretched it like an elastic and then shifted everything up 1. Our next example for the following, write the transformation notation and then indicate where the point would move to. So we're going to start with txy. My k is just 1, so it's going to be x plus 1, 4y plus 2. And we want to take the point 3, 1, so we're going to transform 3, 1 according to that mapping rule. 3 plus 1, 4. 4 times 1 is 4 plus 2 is 6. That should say B, not A. So B, same idea, txy. That's our k value, and it's already been factored out, so we don't have to worry about that. So x over 3. And then even though it looks like a positive 2, remember our d value is negative 2. And then a and c, they're just, nothing's there to affect y, so it's just y. And we're going to take that point, 3, 1. 3 divided by 3 is 1 minus 2, negative 1, and y is unchanged. We're going to keep going with that same type of example here to end. That should say D, not C. txy. My k value is 2, and I don't have a d value, so it's just x over 2. Your a is a fraction, that's okay. So 1/2 y minus 1. My parent point is still 3, 1, so I'm going to transform it. So 3 over 2. And then 1/2 times 1 is just 1/2. Minus 1 is negative 1/2. Again, if fractions aren't your thing and they end up being nice decimals like this, that's okay too. But if you ever have to round or it's like a really long decimal, you should challenge yourself to write it as a fraction. txy. My k value has been factored out. Okay, so this is a good one here. So we know it's x over k, and your k is 1/2. So I'm going to write it a certain way here first, and I'm going to write it a different way. So x over 1/2, and then plus 1. Our d value is 1. Then negative y plus 5. There's nothing wrong with the way that's written, except for some of you are probably thinking, whoa, x over 1/2. I got a fraction and a fraction. That looks messy, especially if you don't like fractions. So let's clean that up a little bit. Now, there's a couple different ways to think about this. On your calculator, you could just type in 1 divided by 1/2, and everyone should get 2. So really this is 2x. The other way to think about this, when you're looking here, 1/2, that's 1 divided by 2, which is really just dividing something in half, dividing it by 2. And I told you x kind of like opposite. What's the opposite of dividing by 2? Multiplying by 2. And you just proved it to yourself, 1 divided by 1/2 is 2. So we could rewrite it like this. That's how I would write it, but if you like the x over 1/2 and then using your calculator, that's fine too. And then we're going to take that point, 3, 1, transform it. 2 times 3 is 6, plus 1 is 7. Negative 1 plus 5 is 4. So that's it. That was a big one, important one. Hopefully it's okay, especially after you get some more practice. Make sure you check D2L for your work. And by the time you've watched this, you're probably going to have already heard from me, but just in case you haven't or you haven't checked D2L, originally I had thought your test would be on Thursday, but based on how things are going to go and how they are going, and some things I've cut out or whatever, I think we're going to have our test on Wednesday afternoon. So again, I haven't mentioned it yet in any of the lessons, but I figure by now, if you don't know, probably you should know now, your test is going to be on Wednesday afternoon. That's it. Thanks for listening. The next lesson, so you know, was recorded in a previous year, which will become very evident when you start watching it and you see the date. Ignore the dates, ignore specific references to like homework or tests, just the content is what matters the most.